So good evening. This is the last major section before we take our test. Our test is going to be next Monday. I don't have the date, but it's going to be next Monday. So make sure this is making sense. Everything we've done today has worked up to try to find some way to solve, to find the solutions, the roots, the zeros of a quadratic equation. Today we're going to find the last example, the last way we can use to solve a quadratic equation, and it's also going to turn out to be a way that we can use on any quadratic equation. So let's go ahead and start by what we've been doing the last couple days of using complex numbers to solve quadratic equations. Just like we've done before, these examples are just examples you can just kind of watch. You've done this before. This is just a quick review. 3x squared plus 10 equals negative 26. If you subtract 10 to both sides, 3x squared is equal to negative 36. Divide both sides by 3. X squared is equal to negative 12. Square root both sides. So x is equal to plus or minus the square root of negative 12. Remember that square root of that negative 1 can become I. The square root of negative 12 is the square root of 4 times square root of 3. So this is plus or minus 2I square root 3. That's how I solve a problem like this. That's how I use the complex numbers to come up with my two answers, which is a nice thing to know and have and be able to see. Excuse that. Wrong page. Here we go. Hide that. So let's do another one of these again. This is just something you can watch to make sure it does make sense to you. I'm going to subtract 26 to both sides. You get 2x squared is equal to negative 36. Divide both sides by 2. You get x squared is equal to negative 18. You square root both sides. You get x is equal to plus or minus. The negative becomes the I. This is square root 9 times square root 3. So the square root of 9 is 3, so this is plus or minus 3I square root 3. Again, there's my answer when I solved it. This was my answer previously, my two answers. This here is my, of course, it would be helpful that we remembered that 9 times 2 is 18, so this is a square root of 2 inside the square root. So it's plus or minus 3I square root 2, not square root 3, but that's my final answer using complex numbers. So one last time, I would do this the same way. I would square root both sides since the thing that's being squared is by itself. This is x minus 1 is equal to plus or minus the square root of negative 7. I know that square root of negative 7, x minus 1 is equal to plus or minus I square root 7. I can then add 1 to both sides. Again, x is equal to 1 plus or minus I square root 7. Again, I have a real part, an imaginary part, and there's my final answer. So we've seen how to solve using complex numbers. And that's going to help us when I use this next part. My next part is I can solve any equation any quadratic equation I want using this particular formula. Everything we've done now is to find easy ways to solve quadratic equations. We could graph it, we could factor it, and today we're going to learn the third way of solving quadratic equations. Excuse me, we could graph it, we could use square roots, and the fourth way, which will always work, is what's called using the quadratic formula. Everyone loves the quadratic formula, but the difference is we actually can use the quadratic formula on any quadratic, not just particular ones. So the quadratic formula is another way to solve quadratic equations. It is important to know because it works for any type of quadratic equation and can be used when none of the other three solution methods work. Given a quadratic equation in standard form, ax squared plus bx plus c. The solutions can be found by x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which you should have heard at least once before, if not twice before. This is the quadratic formula. I need to stop. I need to tell you that this is in your course pack on page 516, not 1516, page 516. So you can follow along. You can do your notes there in the course pack. There is a blank for standard form, and there is a blank for the quadratic formula. Please write these down. Please know them. This is something that has to be memorized. So the quadratic formula is very important. Make sure you know it and you can use it. So ignore that, Bell. So whenever I'm given a problem, the first thing that I want to do is I want to find the easiest way to solve for x. So I look at this, and the first way that I want to do is I want to see, can I factor this? Is there anything that multiplies to be negative 4, since this is basic factoring because a is 1, and add up to be 3? And if I think about this, the numbers 4 and negative 1 will multiply to be negative 4 and add to be positive 3. So I can factor this out to be x plus 4, x minus 1 is equal to 0. So x plus 4 is equal to 0, or x minus 1 is equal to 0. So x is equal to negative 4 or 1. Those are my two solutions for this problem. I didn't have to use the quadratic formula because factoring is easier and it works out really well. But there's that answer. So you want to find the easiest way to solve the problem. It's factoring is the easiest way. You want to factor. Let's try the next one. Here's another problem. It's quadratic because I have an x squared. It doesn't say equals 0, so the first thing I'm going to do is I'm going to subtract 15 to both sides. So I get x squared minus 2x minus 15 is equal to 0. Again, I want to ask myself, is there something that multiplies to be negative 15 and adds to be negative 2? Again, this is basic factoring because their a is 1. What multiplies to be negative 15 and adds to be negative 2? Well, negative 5 and 3 will multiply to be negative 15 and add to be negative 2. So I can factor this. This is x minus 5, and this is x plus 3 equals 0. So x minus 5 is equal to 0, or x plus 3 is equal to 0. Add 5, and I get x is equal to 5. Subtract 3, and I get x is equal to negative 3. Those are my two answers. I can always plug in to check. But again, factoring was the easiest way to solve this, so I factored it. Let's go to my next example. X squared plus 4x plus 1 is equal to 0. So again, what we want to do is we want to ask, can I factor this? So what multiplies, again, this is basic factoring because in front of the x squared is a 1. What multiplies to be 1 and adds to be 4? I can't think of anything else either. I cannot factor this. There is a linear term, there is an x term, so I can't use square roots. So everything that I've done up to this point, I could try to graph this, that's true, but trying to do this algebraically, I want to go ahead and say, hey, I can't factor it, I can't use square roots, let's go ahead and use the quadratic formula. So I'm going to say that in front of this x squared is the number 1, so a is equal to 1. In front of the x is 4, so b is equal to 4. And in front of the constant off by itself is c, and c is 1. So I have my a, my b, and my c. So I write down my quadratic formula. X equals negative b plus or minus the square root. I'll stop singing. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. That's the quadratic formula. It can be solved. Excuse me, this is the solution that solved for x. So I just plug in the numbers that I have. So negative b is going to be negative 4. Let me go a little lower. So x is equal to negative b is going to be negative 4 plus or minus the square root of b squared. So that's 4 squared minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. All I did was plug in numbers. Now let's go ahead and simplify these numbers. This is negative 4 plus or minus the square root of, ignore that, well, 4 squared is 16. 4 times 1 times 1 is 4. So this is going to be 16 minus 4 is 12. 2 times 1 is 2. So this is negative 4 plus or minus. The square root of 12 is the square root of 4 times the square root of 3. The square root of 4 is 2. So this is 2 square root 3 over 2. Extend my page. If I look at this, I can notice that this can be simplified. I can go ahead and write this as negative 4 over 2 plus or minus 2 square root 3 over 2. And I get negative 4 plus or minus the square root of 3. Negative, that's wrong. Negative 4 divided by 2 is negative 2. 2 square root 3 over 2 is 2. So this is negative 2 plus or minus the square root of 3. That is my final answer. That is what x is equal to. And I use the quadratic formula to get there. Since I have a quadratic equation in standard form, I can always use the quadratic formula. There's my answer. Let's try another example. So this example is negative 2x squared equals negative 2x plus 3. Again, these are on your course pack, so follow along. If I look at this, I need to make this equal 0, so I'm going to add 2x minus 3 to both sides. They cancel on the right, so I get negative 2x squared plus 2x minus 3 is equal to 0. Now, the one thing that we said about this, I've said about this earlier, is I really don't want my leading coefficient, my x squared, to be negative. If I can have this be positive, it makes it a whole much nicer of a problem. So I'm going to multiply both sides by a negative 1. On the right side, it doesn't change anything. I still have 0. On the left side, again, I'm going to get 2x squared minus 2x plus 3. I didn't change my problem. I just multiplied both sides by a negative 1. This is something I can do, but my leading coefficient, my a term, is now positive, and it's a lot easier and a lot nicer to do. So if I try to factor this, and again, I always want to try to factor because that's a lot easier, I have California method. So what multiplies to be AC and adds to be B? 2 times 3 is 6, and then B is negative 2. What multiplies to be 6 and adds to be negative 2? Well, multiplies to be 6 are 1 and 6, and 2 and 3. None of those will add up to be a negative 2, so I can't factor this. So I want to go ahead and use my quadratic formula. Scoot up just a little bit. And my quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Now, if you remember back from freshman year or Algebra 1 at least, you will notice that we had a song that went with this that helps people to memorize this. It goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's helpful. I know it's a little bit annoying, but it's helpful. I can go back to my original problem, and I can say, okay, a is going to be 2, b is going to be negative 2, and c is going to be positive 3. I have my a, my b, and my c. I have my quadratic formula, so I just need to plug it in. X is equal to negative 2 plus or minus the square root of negative 2 quantity squared. Be careful of those parentheses. If I put it into my calculator without those parentheses, it's going to give me a negative 4 instead of a positive 4. B squared minus 4 times A is 2 times C is 3, all over 2 times A, which is 2 times 2. I'm going to go ahead and simplify this. Negative 2 is positive 2 plus or minus the square root of negative 2 squared is 4. 4 times 2 times 3. Well, 4 times 2 is 8 times 3 is 24, so that's minus 24 all over 2 times 2, which is 4. I'm showing every gory detail. So then this is equal to 2 plus or minus the square root of negative 20 over 4. Negative 20, I have a negative, so I need to pull out an I. I have a perfect square, which is 4. So this can simplify to 2 plus or minus the square root of 4 is 2. The square root of negative 1 is I. I'm left with the square root of 5 over 4. And again, I can simplify this. Last time I broke it up into 2 fractions. This time what I'm going to do instead is I'm going to factor out a 2 out of my numerator, out of my top. And that's going to be over this 4. It's going to cancel out and reduce with that 4 to give me 2. So I end up with 1 plus or minus I square root 5 over 2, which I can leave as my answer. But if I want this to be a complex number, that will be 1/2 plus or minus I square root 5 over 2. I can go either way. I can leave it as this as my final answer, or I can break it down over the 2. Either way are 2 good answers, and it'll work out, and both of those will work as my solutions. So that's the gist of this. I've used complex numbers, I use square roots, I use the quadratic formula, and it's all part of this style of solving this. Let's try number 5. Again, number 5, I have 2x squared plus x. I'm going to subtract 5 to both sides is equal to 0. Again, I want to double check, can I factor this? What multiplies to be 10 and adds to be 1? Well, what multiplies to be 10 are 1 and 10 and 2 and 5. None of those will give me, actually it's a negative 10. None of those will give me 1. So the only thing I have left, because I cannot factor it, you can even say cannot factor. Since I cannot factor this, I'm going to go ahead and use the quadratic formula. I can see that that's not A, that's a B. I can see that A is 2, B in front of the X is 1, and C is negative 5. So I write down my quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Plug in what I know. I can say negative B is negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 5. Never make that bar long enough. All over 2 times A. And A still is 2. So again, here I want to simplify. So this is negative 1 plus or minus the square root of 1 squared is 1. 4 times 2 is 8. 8 times 5 is 40. But it's negative and a negative, so it's a positive 40 all over 4. So this is negative 1 plus or minus the square root of 41 over 4. Well, the square root of 41 I can't simplify. It's not factorable. So I'm going to go ahead and say that's my answer. Negative 1 plus or minus the square root of 41 over 4. Can't simplify or reduce the 4 down. That's my answer. Let's try the next one. X squared plus 14x minus 49. Again, I want to solve this for, make it equal 0 plus 4x. That's not a 4x. It's supposed to be plus 14x. Add 49, so plus 49 is equal to 0. The nice thing is, again, I want to start by factoring, but I notice that x squared is a perfect square, 49 is a perfect square, and I can see this is x and a 7. X times 7 times 2 is 14x. So I can quickly say this is x plus 7 squared, which is equal to 0. And since it's a double root, I can solve this for x. X plus 7 is equal to 0, so x is equal to negative 7. If you can factor, factor. Factoring is easier than using the quadratic formula, and I do need to remember that this is a double root. But I can factor, and factoring makes it simple and easy. 2 more problems. We're getting there. There's another idea that I have to talk about after that. Number 7, make it equal 0, so it's x squared minus 6x, add 10, so that's plus 10 is equal to 0. Again, see if I can factor this. What multiplies to be 10 and adds to be negative 6? Well, 1 and 10, 2 and 5. None of those are going to give me negative 6, so this cannot be factored. Since it cannot be factored, I'm going to go ahead and use the quadratic formula. A is 1, B is negative 6, and C is 10. So I'm going to plug this into my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's catchy. It helps me remember it, so I use it. Plug in what I know. X is equal to negative 6, which is 6, plus or minus the square root of negative 6 squared minus 4 times 1 times 10 all over 2 times 1. I make sure to write it all out so that I'm plugging things in correctly, so then I can come back and I can say, okay, well, this is x is equal to 6 plus or minus the square root of negative 6 squared is 36. 4 times 1 times 10, negative 6 squared is positive 36. 4 times 1 times 10 is 4, so this is, 40, so this is minus 40 all over 2. So x is equal to 6 plus or minus the square root. 36 minus 40 is negative 4 over 2. Negative 4. 4 is a perfect square. Negative can bring an I out. So x is equal to 6 plus or minus 2i over 2. And again, I can simplify this. I can reduce the 6 and the 2 with the 2 underneath. The 6 and the 2 reduces to a 3, plus or minus the 2 and the 2 reduce to I. So this is 3 plus or minus I. And that's my answer for this quadratic formula. Last example, and then we're going to do the how to make this stuff work. So I'm going to add 256 to both sides. So I get x squared is equal to 256. I did that because there is no x term, there's no linear term, there's a quadratic term, and there's a constant. Since the quadratic term is by itself, I can square root both sides. and I get x is equal to plus or minus, the square root of 256 is 16, and I'm done. That was using square roots, and it was a simple problem because I know that 16 squared is 256. You could use your calculator. Either way, you could simplify it if it wasn't a perfect square. Let's try to see what's on the bottom of this page, the discriminant. The discriminant is b squared minus 4ac. If you remember, when I'm talking about the quadratic equation, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is what's inside the square root. And this is going to tell me if I'm going to have real solutions, imaginary solutions, or one solution. And so we're going to look at to see what kind of solutions I have. It will tell the number how many and type, real or imaginary, of solutions. So if I look at my first case is x squared plus 2x minus 5 equals 0. Wrong page. Excuse me 1 second. My discriminant is going to be what's in the square root, b squared minus 4. Oh, let's do that a little lower. B squared minus 4ac. If I plug in my b, this is 2 squared minus 4 times 1 times a negative 5. So this is 4 minus negative 4 times 1 times negative 5 is plus 20. So this is 24. This is a positive discriminant. So it tells me, so if the discriminant is positive, then the equation has two real solutions. If I was to look at the graph of this, the graph would do something like this, where it crosses the x-axis and give me two real solutions or zeros or roots. But the discriminant tells me that. It tells me I'm going to have two positive. Since the discriminant is positive, I'm going to have two real roots, and it's going to look something like this graph over here. Okay? That's the first case. Case 2. If I look at case 2, my discriminant, again, is b squared minus 4ac. b is 2, so this is 2 squared minus 4 times a is 1. c is 1. 2 squared is 4. 4 times 1 times 1 is 4. 4 minus 4 is 0. So, if the discriminant is 0, then the equation will have one real solution, and this is what we call our double root. And what the graph of that looks like is I'm going to come and I'm going to hit the x-axis, and it's just going to be the vertex. The vertex itself is on the x-axis, so that is my double root. And so if my discriminant is 0, I know I am going to have one solution, a double root, and I know it's going to be real. My last case here, x squared plus 2x plus 5 equals 0. Again, I want to use my discriminant, so it's b squared minus 4ac. b is 2, so this is 2 squared minus 4 times 1, which is a, times 5, which is c. 2 squared is 4. 4 times 1 times 5 is 20. 4 minus 20 is negative 16. My discriminant is negative, so if the discriminant is negative, then the equation has two imaginary solutions. How does that graph? That graph is going to look like it's going to come down, and it's never going to touch the x-axis. All my solutions are imaginary. I never cross my x-axis, so I never have any real solutions. That is our everything that we've done. This is a long set of notes. It took me 30 minutes. I'll make sure that you have enough time. I'll tell you today to make sure that you have enough time to listen to this. That's this discriminant that's solving using the quadratic formula. Have a good day.